So in this one, we're going to take the derivative implicitly. This is going to involve a chain rule. So let's write that out. So u is going to be that inside stuff, sine of pi x plus cosine of pi y. Now remember, there's an understood parentheses here around pi y and an understood parentheses here around pi x. Du is going to be the derivative of that. Okay, and this is involving a chain rule also. The derivative of sine of pi x, when we know derivative of sine is cosine. And then you have to take the derivative of the inside function. The derivative of this is going to be pi, and I'm going to write that pi in front. So now we need to take the derivative of the cosine. We know derivative of the cosine is negative sine. But then you have to take the derivative of the angle. The derivative of the angle is going to be pi. And we have to show we took that derivative with respect to x because it's in terms of y. So we're going to tack on that y prime. So the derivative of cosine of pi y is in itself a chain rule. It's going to be the negative sine of pi y times pi y prime. So we would do a rewrite. This would be u squared. The derivative of u squared is 2u du. And then if we substitute everything back in, u is sine of pi x plus cosine of pi y. And du is all this fun stuff. So pi cosine pi x minus pi y prime sine of pi y. So when I take the derivative of the left, I'm going to have 2 times sine of pi x plus cosine of pi y times pi cosine pi x minus pi y prime sine of pi y. And we know the derivative of 2 is just 0. Now remember the goal. The goal is to get y prime by itself. So I'm going to divide both sides by 2 sine of pi x plus cosine of pi y. What I do to the left, I got to do to the right because math is always fair. Excuse me. So let me move this up here. So we're going to have pi cosine pi x minus pi y prime sine of pi y is equal to 0. I'm going to move the sine term to the other side. And then to get y prime by itself, I'm going to divide by pi sine of pi y. So y prime is going to be cosine of pi x divided by sine of pi y. So there's our derivative. So now that we know how to find the derivative, let's use it to find the slope of a graph at a particular point. Let's do this problem, number 31. So we want to find the derivative of the function, tangent of x plus y is equal to x, and then evaluate it at the point 0, 0. Notice the direction is asking us for the slope of the graph. Slope of the graph is can be found using that derivative. The derivative of the tangent is secant squared. And then we're going to take the derivative of the inside. This is actually a chain rule problem. So we could write it out if we wanted to using the U-step process. So derivative of the outside function, secant squared. The derivative of the inside is x. Derivative of x is 1. Derivative of y is y prime. The derivative of x is 1. Goal is to solve for y prime. So I'm going to divide both sides by the secant squared. So y prime is equal to 1 over secant squared, which is the same thing as cosine, minus 1. So there's our derivative. Now they're asking us to evaluate the derivative at 0, 0. So when we write that, normally when we evaluate a derivative of a function in terms of x, then we would plug in just an x value. Maybe that x value is 2, and then we would just substitute 2 into the function. Here is a little bit different because it's in terms of x and y. So when we write that, and I like to write it this way, I'm going to put that point in a subscript form. That way it shows what I'm plugging in here. So I'm going to have cosine squared of 0 plus 0 minus 1. Well, that's going to be cosine squared of 0. And cosine of 0 is just 1. And 1 minus 1 is 0. So that value of the derivative there is going to be 0. Which means the slope of that secant line is going to be 0. And then we're going to do one more example. In this set, they're asking us to find the second derivative. So the second derivative has just a little bit of a trick to it because we have to make a substitution. So let's work through that first one, number 49. We have x squared plus y squared is equal to 4. So this is the equation of a circle. To take the derivative, we're going to have 2x plus 2y, y prime, is equal to 0. Solve for y prime. We're going to subtract 2x. Then we're going to divide everything by 2y. So there's our derivative. Negative x over y. Now, they're asking us for the second derivative. The derivative of the first derivative is the second derivative, so there's my y prime. And then I'm going to have to use the quotient rule here. Quotient rule, and I'm just going to go ahead and apply it. It says it's the bottom times derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, now notice that when we took that derivative, we ended up with a y prime in here. This is where we're going to do a substitution. You have to substitute in for that y prime because you want everything in terms of x's and y's, not in terms of the derivative. So that's an important thing to write down in your notes. So let's make that substitution. We have negative y plus x times y prime, which was negative x over y squared. So we have negative y minus x squared over y squared. And I'm going to get rid of this complex fraction by multiplying the top and the bottom of the big overall fraction by y. So I'm going to have negative y squared minus x squared over y cubed. And I could leave it like that, or if we wanted to, we could factor a negative out of the top. And then I want you to notice something here. Remember in the beginning, it told us x squared plus y squared is equal to 4. So we could do another substitution here. So we could simplify this even more in this case because x squared plus y squared is equal to 4. So that second derivative is actually written just in terms of the y value. Okay, sometimes that won't happen where we can make another substitution, sometimes it can't.